All right, welcome back. Today, we're going to tackle a really critical decision that pretty much every AI developer has to face at some point, picking the right foundation model for the job. And to make this super practical, let's frame it like an exam question. It'll really help sharpen our thinking. So let's just dive right in. Okay, here's the challenge. Picture this. You're building an app for real-time, on-the-fly speech translation. So when you're picking your pre-trained model, what's your number one priority? Is it A, the model's size and complexity? B, its latency and multilingual skills? C, the input/output length? Or D, RAG compatibility? Go on, take a sec. What's your gut feeling? And the correct answer is B. If you got that, nice one. But, the real learning here isn't just getting it right. It's understanding why it's right. So let's break down the two parts of that answer. So for this specific task, you've got two things that are absolutely non-negotiable. They're equally important. First, you need a lightning-fast response. That's what we mean by low latency. And second, the model has to be, well, good at its main job, right? It needs to handle a bunch of languages really well. You can't have one without the other. If either one of these is off, the whole app is basically useless. Let's talk about latency for a second, because it's so important for the user. It's that awkward pause, the delay between when you speak and when you get the translation back. In any app that claims to be real-time, high latency is just a total deal breaker. It makes for a clunky, frustrating experience, and nobody wants that. Okay, so now for the really interesting part. Let's dig into why the other options are wrong. I mean, they're not bad things to consider in general, but for this specific job, they just aren't the number one priority. Getting this right is how you develop those sharp instincts for building great AI. So what about option A, model size and complexity? I mean, it's a tempting one, right? It's so easy to fall into the trap of thinking bigger is always better. More parameters, more complexity, that's gotta be the best, doesn't it? And look, model size is important, for sure, but it's just not the main character in this story. The moment you see that keyword real time, everything else kind of has to take a backseat to speed. Think about it. What good is a massive, super smart model if it takes 5 seconds to translate one sentence? It's totally useless for a live conversation. In this case, speed absolutely beats size, no question. All right, on to option C, input and output length. This one sounds pretty important too, doesn't it? And yeah, it matters, but it's super task dependent. If your goal was, say, text summarization, where you're feeding it a huge document and asking for a summary, then yeah, input length is a massive deal. But for translating a sentence here, a phrase there, in a live conversation, it's just not the main thing slowing you down. The real bottleneck is the processing speed itself, not the length of what you're saying. And that brings us to our last option, D, RAG compatibility. Now, RAG is a super powerful tool in the AI world, but is it the right tool for this job? So what RAG, Retrieval Augmented Generation, really does is connect a model to outside knowledge, like a database or a bunch of documents. It's amazing for things like a customer service bot that needs the latest company info. But for the pure act of translating language, it doesn't make the translation faster or more accurate. It's just not relevant. It's like bringing a screwdriver to hammer a nail. Wrong tool for the job. Okay, so we've walked through all the options. And what this really boils down to is a simple, powerful rule of thumb. This is the key thing you need to remember next time you're faced with a problem like this. Here it is, plain and simple. If a task is described as real-time, your first thought has to be low latency, period. And if the task is translation, well, of course you're going to need great multilingual support. Our problem had both of those keywords, which is exactly why B, with its two parts, was the perfect answer. So, now you know exactly how to approach this kind of problem. To really lock it in, let's leave you with one more question. Using this exact same logic, what would you prioritize for a real-time code completion model? The kind that suggests code as you type. What's the real-time priority there? And what's the core task you need the model to be good at? I'll let you think on that one.